Welcome to our one-shot journey into the fascinating world of gravitation. Today we'll unravel the mysteries behind the force that keeps our feet on the ground and the planets in their orbits. Gravitation is one of the fundamental forces of nature, affecting everything with mass from the smallest pebble to the largest galaxy. In this video we'll explore what gravitation is, how it was discovered, and why it's so essential to our understanding of the universe. Let's begin by understanding what gravitation actually means and how it impacts our everyday lives. Gravitation, often called gravity, is the force of attraction between any two objects with mass. It's the reason why apples fall from trees and why we stay anchored to the earth. This invisible force acts at a distance, pulling objects toward each other. The more massive an object, the stronger its gravitational pull. Even though we can't see gravity, we can observe its effects everywhere, from falling objects to the motion of planets. Understanding gravitation helps us make sense of the physical world around us. The story of gravitation dates back centuries. Ancient philosophers noticed that objects fall toward the ground, but it wasn't until Isaac Newton's time that the concept was truly understood. In the 17th century, Newton formulated the law of universal gravitation, stating that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. This groundbreaking idea changed the way we view the universe and laid the foundation for modern physics. Newton's law of universal gravitation can be summarized with a simple equation: F equals g m1 m2/r2. Here F is the gravitational force, g is the gravitational constant, m1 and m2 are the masses of the objects, and r is the distance between their centers. This law explains why the Earth pulls us down and why the Moon orbits the Earth. It applies to all objects, no matter their size or location in the universe. Newton's insight was revolutionary, providing a mathematical framework for understanding gravity. On Earth, gravity gives us weight and keeps everything grounded. It's why water flows downhill, why objects fall when dropped, and why we can walk without floating away. The strength of gravity on Earth is determined by the planet's mass and radius. At sea level, the acceleration due to gravity is about 9.8 meters per second squared. This value is nearly constant everywhere on Earth, making our daily experiences with gravity predictable and reliable. It's important to distinguish between weight and mass. Mass is the amount of matter in an object and remains constant regardless of location. Weight, on the other hand, is the force exerted by gravity on that mass. For example, your mass is the same on Earth and the Moon, but your weight is less on the Moon because the gravitational pull is weaker. This distinction is crucial in physics and helps us understand how gravity affects different objects. Gravity isn't the same everywhere in the universe. Different planets have different masses and sizes, which means their gravitational pull varies. For instance, Jupiter has much stronger gravity than Earth, while the Moon's gravity is only about 1/6 as strong. This difference affects everything from how high you can jump to how much you would weigh on each planet. Exploring gravity on other worlds helps scientists understand planetary formation and the conditions needed for life. When an object falls freely under gravity, it accelerates toward the ground at a constant rate, ignoring air resistance. This acceleration is called g and is approximately 9.8 ms2 on Earth. All objects, regardless of their mass, fall at the same rate in a vacuum. This was famously demonstrated by Galileo, who dropped different objects from the Leaning Tower of Pisa. Free fall is a key concept in understanding how gravity works in the real world. Galileo Galilei challenged the ancient belief that heavier objects fall faster than lighter ones. In his famous experiment, he dropped two spheres of different masses from the Leaning Tower of Pisa and observed that they hit the ground at the same time. This experiment proved that in the absence of air resistance, all objects fall at the same rate. Galileo's work laid the groundwork for Newton's later theories and changed our understanding of motion and gravity. Newton's universal law of gravitation states that every object attracts every other object in the universe. The force of attraction depends on the masses involved and the distance between them. This law applies not just to objects on Earth but to planets, stars, and galaxies. It explains why the planets orbit the Sun and why the Moon orbits the Earth. The universal law of gravitation is a cornerstone of classical physics. Gravitational constant, represented by g, is a key part of Newton's law of gravitation. It's a fixed value that determines the strength of the gravitational force between two objects. The value of g is approximately 6.674 times 1011 nm2/kg2. This tiny number shows that gravity is actually a very weak force compared to others, like electromagnetism. However, because gravity acts on all mass, its effects are significant on large scales. Gravity is responsible for the orbits of planets, moons, and satellites. When an object moves fast enough sideways as it falls, it keeps missing the ground, creating an orbit. This is how the Moon stays in orbit around Earth and how artificial satellites circle our planet. The balance between gravitational pull and forward motion creates stable orbits, which are essential for everything from GPS to space exploration. The gravitational pull of the Moon causes tides on Earth. As the Moon orbits our planet, its gravity pulls on the oceans, creating bulges of water that we experience as high and low tides. The Sun also affects tides, but to a lesser extent. Understanding tides is important for navigation, fishing, and coastal management. This is a direct example of how gravity influences our daily lives. Astronauts in space often appear weightless, but gravity is still at work. In orbit, astronauts are in a constant state of free fall toward Earth, but because they're moving forward so quickly, they keep missing it. This creates the sensation of weightlessness. Understanding this helps explain why astronauts float in space and how gravity affects objects even far from Earth. Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. Instead of viewing gravity as a force, Einstein described it as the curvature of spacetime caused by mass. Massive objects like the Sun bend the fabric of spacetime, and this curvature tells planets how to move. Einstein's theory has been confirmed by many experiments and is essential for understanding phenomena like black holes and gravitational waves. Spacetime is the four-dimensional fabric that combines space and time. According to Einstein, mass and energy can curve this fabric, creating what we perceive as gravity. The greater the mass, the more spacetime is curved. This concept explains why planets orbit stars and why light bends around massive objects. Spacetime curvature is a key idea in modern physics and helps us understand the universe on a deeper level. Gravitational waves are ripples in spacetime caused by massive accelerating objects, like merging black holes or neutron stars. Predicted by Einstein, these waves were first detected in 2015 by the LIGO Observatory. Gravitational waves carry information about cosmic events billions of light years away, opening a new window into the universe. Their discovery is one of the most exciting breakthroughs in modern physics. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity. Black holes warp spacetime to an extreme degree, creating fascinating phenomena like event horizons and gravitational lensing. Studying black holes helps scientists test the limits of our understanding of gravity and the laws of physics. Gravitational lensing occurs when massive objects like galaxies bend light from objects behind them. This effect, predicted by Einstein, allows astronomers to observe distant galaxies and study dark matter. Gravitational lensing acts like a cosmic magnifying glass, revealing details that would otherwise be invisible. It's a powerful tool for exploring the universe and understanding the distribution of mass in space. Gravity doesn't just affect space, it also affects time. According to general relativity, time runs slower in stronger gravitational fields. This phenomenon, known as gravitational time dilation, has been confirmed by experiments with atomic clocks. For example, clocks on satellites run slightly faster than those on Earth's surface. Understanding time dilation is crucial for technologies like GPS, which rely on precise timing. Gravity is the glue that holds the solar system together. It keeps the planets in orbit around the sun and governs the motion of moons, asteroids, and comets. Without gravity, the solar system would fly apart. Understanding how gravity shapes the solar system helps us predict planetary motion and explore new worlds. Gravity plays a crucial role in the life cycle of stars. It causes clouds of gas and dust to collapse, forming new stars. Gravity also drives nuclear fusion in the cores of stars, producing the energy that makes them shine. When stars die, gravity can create white dwarfs, neutron stars, or black holes. Studying gravity helps us understand how stars are born, live, and die. On even larger scales, gravity shapes galaxies and clusters of galaxies. It pulls stars together to form galaxies and binds galaxies into clusters. Gravity also influences the motion of stars within galaxies, providing evidence for the existence of dark matter. Understanding gravity on these scales helps us unravel the structure and evolution of the universe. Dark matter is a mysterious substance that doesn't emit light but exerts gravitational pull. Astronomers detect dark matter by observing its gravitational effects on galaxies and galaxy clusters. Without dark matter, galaxies would not hold together as they do. Studying gravity helps scientists search for and understand this elusive component of the universe. Microgravity is a condition where the effects of gravity are greatly reduced, such as aboard the International Space Station. In microgravity, objects appear to float, and everyday activities become challenging. Scientists study microgravity to understand its effects on the human body and to conduct experiments that are impossible on Earth. This research is vital for long-term space exploration. Gravity affects our bodies in many ways. On Earth, it helps keep our bones and muscles strong. In space, the lack of gravity can lead to muscle atrophy and bone loss. Astronauts must exercise regularly to counteract these effects. Understanding how gravity influences the human body is essential for planning long-duration space missions and keeping astronauts healthy. Gravity is at work in countless ways every day. It keeps our drinks in cups, helps us walk, and allows us to play sports. Engineers and architects must consider gravity when designing buildings and bridges. Even simple activities like pouring water or riding a bike rely on gravity. Recognizing gravity's role in daily life helps us appreciate this invisible but essential force. Modern technology depends on our understanding of gravity. From launching rockets to predicting satellite orbits, gravity is a key factor. Technologies like GPS require precise calculations that account for gravitational effects. Even roller coasters and elevators are designed with gravity in mind. Mastering gravity allows us to build safer, more efficient machines and explore beyond our planet. Space travel would be impossible without understanding gravity. Rockets must overcome Earth's gravity to reach space, and spacecraft use gravity assists from planets to gain speed. Astronauts experience microgravity, which affects their bodies and equipment. Planning missions to the Moon, Mars, or beyond requires careful calculations of gravitational forces. Gravity is both a challenge and a tool for space exploration. Gravity plays a big role in sports. It affects how balls fly, how athletes jump, and how we move. Understanding gravity helps athletes improve their performance and coaches develop better training techniques. From basketball to gymnastics, mastering gravity can make the difference between winning and losing. Sports science uses gravity to analyze and enhance athletic abilities. Architects and engineers must account for gravity when designing buildings and structures. Gravity determines how much weight a structure can support and influences the choice of materials. Skyscrapers, bridges, and even homes are built to withstand gravitational forces. Understanding gravity ensures that structures are safe, stable, and long-lasting. Gravity affects all forms of transportation, from cars and trains to airplanes and ships. Engineers design vehicles to work efficiently with gravity, ensuring stability and safety. For example, airplanes generate lift to overcome gravity while cars rely on gravity for traction. Understanding gravity helps us build better, safer transportation systems. Gravity influences weather patterns by affecting the movement of air and water. It causes rain to fall, rivers to flow, and ocean currents to circulate. Gravity also helps form clouds and drives the water cycle. Meteorologists use gravity to predict weather and understand climate systems. Without gravity, Earth's atmosphere would drift away, making life impossible. Plants rely on gravity to know which way to grow. Roots grow downward while stems grow upward, a process called gravitropism. Gravity helps plants anchor themselves and reach for sunlight. Scientists study how plants respond to gravity to improve agriculture and grow food in space. Understanding gravity's role in plant growth is vital for sustaining life on Earth and beyond. Animals have evolved to live with gravity. Birds use gravity to glide, fish rely on it to swim, and humans walk upright thanks to gravity's pull. Some animals, like astronauts, must adapt to different gravitational environments. Studying how animals interact with gravity helps scientists learn about evolution, adaptation, and the possibilities for life on other planets. Gravity is essential for the movement of water on Earth. It causes rivers to flow, rain to fall, and oceans to stay in their basins. Gravity also drives the water cycle, moving water from the atmosphere to the ground and back again. Without gravity, life as we know it would not exist, as water would not be able to circulate or support ecosystems. Gravity can be harnessed to produce energy. Hydroelectric power plants use gravity to move water through turbines, generating electricity. Gravity also plays a role in geothermal and tidal energy. By understanding and utilizing gravity, we can develop sustainable energy sources that benefit society and the environment. Artists often use gravity in their work, from sculptures that balance delicately to paintings that use dripping techniques. Gravity influences how materials move and interact, creating unique effects. Understanding gravity allows artists to experiment with new forms and push the boundaries of creativity. Art and science come together in surprising ways through gravity. You can explore gravity with simple experiments at home. Drop different objects and observe how they fall, or use a pendulum to see gravity in action. Building models of the solar system or creating water rockets are fun ways to learn about gravity. These hands-on activities make science exciting and help deepen your understanding of this fundamental force. Gravity will continue to shape our future, from space exploration to new technologies. Scientists are researching ways to harness gravity for energy, develop artificial gravity for space habitats, and explore the effects of gravity on health and biology. As we push the boundaries of knowledge, gravity remains a key player in our quest to understand and explore the universe. Teaching gravity is an important part of science education. From classroom demonstrations to interactive simulations, educators use a variety of tools to help students grasp the concept. Understanding gravity lays the foundation for learning about physics, astronomy, and engineering. Inspiring curiosity about gravity encourages the next generation of scientists and explorers. Gravity has inspired philosophical questions for centuries. Why does gravity exist? Is it a property of space or something deeper? Philosophers and scientists alike ponder the nature of gravity and its role in the universe. Exploring these questions helps us appreciate the mysteries of existence and the limits of human knowledge. Despite centuries of study, gravity still holds many mysteries. Scientists are searching for a quantum theory of gravity that unites it with the other fundamental forces. Questions about dark energy, black holes, and the origins of gravity remain unanswered. The quest to understand gravity drives scientific discovery and pushes the boundaries of what we know. Gravity is a popular theme in movies, books, and art. Films like Gravity and Interstellar explore its effects in dramatic ways, while science fiction imagines new possibilities for manipulating gravity. Popular culture helps bring scientific concepts to a wider audience, sparking interest and imagination about the universe. In this one-shot exploration, we've seen how gravity shapes everything from falling apples to the motion of galaxies. It's a force that connects us to the universe and drives scientific discovery. Whether you're an aspiring scientist or just curious about the world, understanding gravity opens up new ways of seeing and exploring reality. Thanks for joining us on this journey through the wonders of gravitation.